Imagine this. In the blink of a cosmic eye during its fiery perihelion passage, the interstellar wanderer 3I Atlas defied every prediction, accelerating in a way that shatters our models of natural behavior. Picture a colossal enigma from the stars, not just gliding through our solar system, but actively maneuvering, thrusting forward with precision that screams intentionality. Is this the smoking gun of extraterrestrial engineering, a bold demonstration of advanced propulsion right under our watchful telescopes, or a baffling natural anomaly that forces us to rewrite the laws of cometary physics? This isn't science fiction, it's unfolding astronomical reality, backed by irrefutable data and rigorous analysis. If you turn away now, you'll miss the chapter that could redefine our place in the universe. Stay with me, I'm peeling back every layer of this mind-bending development, and by the end you'll stare at the night sky with a mix of awe and urgent curiosity. We had a small victory. We reduced the number of viewers who watch our videos without subscribing from 97% to 95%. That means 95% of the people who see our videos still aren't part of our community. If you want to give us that support and ensure we can keep creating, please hit that subscribe button. That's real progress, showing the power of our community coming together to fuel more deep dives into the cosmos. But imagine what we could achieve if we push it even lower, unlocking exclusive content, live Q&As, and behind-the-scenes insights for everyone. If you're ready to join the movement and help us hit new heights, hit that subscribe button right now. Your action today could inspire thousands more to explore the universe with us. Hello everyone, I'm Michio Kaku, theoretical physicist, futurist and author of best-selling books such as Physics of the Impossible, The Future of Humanity, Quantum Supremacy and the God Equation. As we embark on this cosmic journey together, I want to make it truly global. Tell me in the comments below, from which corner of our beautiful planet are you tuning in? Whether it's the bustling streets of New York, the neon glow of Tokyo, the vibrant energy of São Paulo, or a serene village under the Southern Cross, your city helps paint a map of our shared wonder for the stars. Sharing where you're from not only connects us as a worldwide family of explorers, but also sparks fascinating discussions about how the night sky looks from your vantage point. Let's build that community bond and see how far our curiosity spans. Today I'm electrified to update you on the interstellar object known as 3I Atlas, which has just delivered a bombshell during its closest solar approach. What was once a tantalizing puzzle has escalated into a potential paradigm shift, with implications that ripple through science, technology, and the very fabric of human existence. As we stand here on November 3, 2025, mere days after this event, the data is fresh, the debates are raging, and the possibilities are boundless. Let me guide you through this revelation step by step, because understanding it could unlock secrets of the cosmos we've only dreamed of, or confront us with realities we've long pondered in the quiet of night. To set the stage, recall the foundational story of 3I Atlas, which I explored in depth previously. Discovered on July 1, 2025, by the Atlas Telescope Network in Hawaii, Chile, and South Africa, this behemoth, potentially 5.6 kilometers across, hurtled into our system at a staggering 58 kilometers per second, far outpacing Earth's 30 kilometers per s, or even Mercury's 48 kilometers per s. Its hyperbolic trajectory marked it as an interstellar interloper, not bound to our sun, destined to swing by and vanish into the void. But anomalies piled up in early coma beyond Jupiter, dominated by carbon dioxide over water, extreme negative polarization in its light, a five-fold brightness surge in May-June, far beyond expectations, and that eerie metallic signature, nickel without iron, initially only for iron to appear later, as if adapting its composition. Contrasted with predecessors like Oumuamua's tumbling cigar shape and Borisov's classic cometary outgassing, fueled speculations from Harvard's Avi Loeb that Atlas might be no mere rock, but an engineered artifact, perhaps a Trojan horse concealing probes, or tech from distant civilizations. Now fast forward to October 29, 2025, perihelion, when Atlas grazed the Sun at 0.7 astronomical units, about 105 million kilometers, closer than initially projected and inside Mars's orbit. Bathed in intense solar radiation of around 770 watts per square meter, any natural comet should have erupted in spectacular fashion, ices sublimating, coma expanding, perhaps even fragmenting into a dazzling display. But Atlas, it held its form visually, with moderate gas production observed by Hubble, yet something extraordinary occurred. Precise measurements from multiple observatories revealed an unexpected acceleration, a velocity boost of approximately 300 meters per second, beyond gravitational predictions. That's the speed of sound on Earth, seemingly minor, but in the vast arena of orbital mechanics, it's monumental. This delta V altered its trajectory subtly, but significantly, shifting its outbound path to pass closer to Mars, now at 160,000 kilometers on January 31, 2026, down from the original 280,000 kilometers, within the orbit of Mars's moon Deimos. Let me be crystal clear on the data. Standard models, rooted in Keplerian orbits and solar gravity, forecasted a specific speed at perihelion, based on Atlas's inbound momentum. Instead, we clocked it higher, with the thrust building gradually over 18 hours, peaking within 2 hours of closest approach, and tapering off over the next 12, a 30-hour window of sustained directional acceleration. Crucially, this vector aligned precisely with its direction of travel, boosting speed along the velocity path, not randomly or perpendicularly as typical outgassing might. This is no haphazard venting, it's trajectory optimization, exploiting the Oberth effect, where thrust at the orbit's lowest point maximizes energy change, like pushing a swing at its nadir. In my decades studying theoretical physics, from string theory's multidimensional realms to quantum supremacy's computational frontiers, I've seen how subtle forces can yield profound outcomes. Here 300 m/s is enough to reshape an interstellar journey, perhaps enabling future maneuvers, or even orbital insertion. NASA's preliminary explanation leans on asymmetric outgassing irregular surfaces, channeling gas jets in a fortuitous alignment. They've cited past comets with non-gravitational accelerations, deeming this unusual but plausible. Yet the math doesn't add up. For a 400 to 600 meter object, let's conservatively estimate its mass in the billions of kilograms. To gain 300 m/s via outgassing at typical exhaust velocities of 500 m/s, it'd require ejecting roughly 60% of its mass. That's catastrophic. We'd see massive plumes, coma ballooning, and spectroscopic spikes in gas, far beyond the moderate levels Hubble detected. No such drama unfolded. The object remained visually subdued, its coma stable. If subsurface pressures released explosively through aligned cracks, infrared would reveal hotspots, and we'd detect the volatile spectroscopically at thrust-consistent volumes. Nothing. Rotation-induced jetting. Atlas spins every 11.7 hours. Any vent would pulse, creating oscillatory acceleration over rotations, but the profile was smooth, sustained across multiple periods, shape effects from extreme asymmetry. Models show that requires engineered geometries, not natural, and even then, thrust averages out over spins. These alternatives strain credulity, especially layered atop Atlas's prior oddities, that ecliptic plane entry within 3 degrees, improbably precise in isotropic space, the premature CO2-dominated coma at -200 degrees Celsius distances, the negative polarization suggesting specular surfaces or metamaterials, the phased metallic revelations, as if unveiling layers. Detractors argue for naturalistic outliers, an eccentric comet from a CO2-rich stellar nursery, but the cumulative improbabilities fray. As Loeb might say, empirical evidence demands we consider the engineered hypothesis, advanced propulsion, perhaps ion drives with 10x higher exhaust velocities, achieving the delta V with minimal mass loss, below detection thresholds. nuclear or chemical systems could do it stealthily. This wasn't random. It was timed for maximum efficiency and observability, perhaps a deliberate signal. We're not natural, we have agency. Notice us. The trajectory shift heightens the stakes. Post-perihelion, Atlas now arcs closer to Mars, offering a prime flyby window in 93 days. Originally a distant pass, it's now surveillance close, ideal for data gathering on our Martian endeavors. China, with strategic foresight, has redirected their rapid launch probe, not to chase Atlas outright, but to intercept at Mars, observing with proximity instruments without velocity matching fuel costs. Brilliant. The US debates diverting a Mars orbiter, like NASA's Perseverance companions, though it trades fuel for mission life. Europe's Mars Express runs simulations for orbital tweaks to snag high-res images without compromise. Decisions loom. Orbital lead times demand action within weeks, or fuel burns escalate. If propulsion is at play, assumptions crumble. We thought Atlas a passive flyby visitor, now it could break orbit or deploy. This perihelion burn prograde, adding velocity, might be step 1 in a sequence, raising the far-end orbit for later decelerations. Near Mars, combining gravity assist with another thrust, could drop speed, binding it to the Sun in an elliptical path. Minimal fuel, maximal effect. Von Neumann probes, self-replicating machines from advanced societies, might operate thus, seeding systems stealthily. Or perhaps the acceleration was demonstrative, priming us for contact. Pre-maneuver, we scanned for natural emissions. Now arrays like ALAN and VLA hunt structured signals across frequencies, with AI sifting patterns. If transmissions follow, we'll recognize them as tech. This elevates Atlas from curiosity to potential security concern. Maneuverability implies intent, course changes, targeting deployments. I'm not alarmist, hostility is unlikely, but prudence demands preparation. The Department of Defense tracks continuously via classified assets. Briefings unfold. Globally, we need coordination. UN Outer Space Affairs convening data-sharing pacts. Protocols for anomalies. Crowdsourcing analysis via open publication could yield breakthroughs. Secrecy limits genius. Public discourse is vital. Managed info risks paternalism. Eroding trust. People deserve truth. This affects all. In Policy Echoes, Loeb's Black Swan document urges readiness for transformative events. Atlas embodies that Trojan horse potential, veiling tech beneath cometary guise. If natural, it revolutionizes volatile mechanics, demanding textbook rewrites. If artificial, its first contact via observation, propulsion defying nature, revealing intelligence. The Fermi paradox, where are they, finds answer in automated emissaries, disguising to observe without alarm. Looking ahead, Mars flyby in January could confirm additional burns, surface glints, via orbiters, transmissions. Earth's closest on December 19, 2025, 267 million kilometers, might see Christmas gifts per Loeb, probes arriving for sampling, relay or surveillance. By March 16, 2026, Jupiter skim at 54 million kilometers lets Juno probe for thermals, radio anomalies, or antimatter hints, spurring innovations. From My Vista, probing multiverses and quantum realms, Atlas enlightens. It challenges solitude, hinting at cosmic company via tech. Empirical vigilance trumps conjecture. Observatories, attuned data flows. What will the next 93 days reveal? Mundane resolution or epochal pivot. Like Copernicus' heliocentrism or Einstein's relativity, Atlas could catalyze leaps, astrophysical insights, biochemistries, engineering marvels, even panspermia confirmation. To deepen our grasp, let's dissect the underpinning science with greater granularity. Atlas's hyperbolic orbit embodies celestial mechanics elegance, eccentricity surpassing unity yields, an unbound parabola asymptotically approaching infinity with excess velocity insulating against solar capture. Detected near Jupiter, its 58 km per s outpaced local Keplerian velocities, affirming extrasolar pedigree unequivocally. Simulations suggest Ophiuchus origin, a constellation in our galaxy's plane, but the precise alignment with the ecliptic, within a mere 3 degrees, defies random chance in the three-dimensional void, where probabilities favor scattered arrivals. This precision optimizes encounters with inner planets, fueling debates on intentionality. Dimensional assessments derived from photometric data, absolute magnitude calibrated against presumed albedo, yields the 5.6 km ceiling. Should surfaces gleam metallically, estimates contract. If absorptive and dusty, they inflate, underscoring observational ambiguities. Models propose lobe symmetry, perhaps bilobate like many asteroids, but the five-fold brightness escalation from May to June versus the forecasted 1.5x intimates eruptive episodes, conceivably internal energetics, fracturing veneers or volatilizing reservoirs. X-ray hints, if present, could suggest fusion processes, though none were confirmed pre-perihelion. Polarization intricacies, scattered photons encode surface narratives, positive for rugose, particulate media, negative for specular or fine-grained auras. Atlas's nadir, negativity evokes mirrored facets, or bespoke aerosols, discordant with cometary dishevelment. This aligns with metamaterials, engineered substances that manipulate light in unnatural ways, perhaps cloaking underlying structures. Spectroscopic coma profiling, via Hubble and terrestrial scopes, spotlighted CO2 dominance through emission spectra, overshadowing H2O bands. Archetypal comets boast 90% aqueous ices. Atlas's reversal posits gestation in carbon star vicinities, or synthetic formulations. Isotopes imply exotic origins, potentially from systems with carbon-rich giants. The metallic disclosures add another layer. Ultraviolet absorptions flag nickel sans iron preliminarily. Nebular condensation forges Phe indissolubly. This junction necessitates thermal or chemical fractionation. Nickel's elevated melting point, 1455 degrees Celsius, versus iron's 1538 degrees Celsius, or selective volatilization. September's iron infusion, potentially stratigraphic unveiling, where deeper layers expose as outer erode, or orchestrated dispensation to assimilate norms. This mimics camouflage, progressively normalizing to evade scrutiny. Venusian rendezvous on November 3rd, today at 97 million kilometers, offers no direct peril, yet it's opportune for probe launches, leveraging perturbations for slingshots toward Earth or Mars. Though past now, any deployments might still be en route, invisible until atmospheric entry. The European Space Agency's JUICE mission, en route to Jupiter's icy moons, stands poised to intersect Atlas's path this week. Its suite of instruments, including high-resolution imagers, spectrometers, and particle detectors, capable of capturing unprecedented details, anomalous fragmentations that don't dissipate as cometary debris would, unexplained thermal emissions suggestive of onboard power sources, or even fleeting glimpses of detached substructures. Imagine JUICE relaying images of metallic glints, proving design, though solar glare post-perihelion might still obscure. Loeb's Galileo project, with its 3 dedicated observatories, equipped with advanced optical, infrared and radar capabilities, is ramping up surveillance of Earth's atmosphere. In the coming months, they'll vigilantly scan for unconventional intrusions, swift, non-meteoric objects that might represent incoming probes, distinguishable by their trajectories, compositions or electromagnetic footprints. This proactive stance underscores the project's ethos to empirically investigate unidentified aerial phenomena and potential interstellar artifacts without preconceived biases. Early data hints at anomalies potentially linked to Atlas, though confirmation awaits. As we project forward, December 19, 2025, merely 6 days shy of Christmas, heralds Atlas's closest terrestrial approach, at 267 million kilometers, roughly twice the Earth-Mars opposition distance. Should probes have detached during or post-perihelion, this window could facilitate their arrival, whimsically termed Christmas gifts by Loeb, potentially bearing payloads of scientific instruments for atmospheric sampling, communication relays for interstellar dialogue, or surveillance apparatuses for unobtrusive observation. The ethical and existential quandaries abound. How would humanity respond to such overtures? Would they foster collaboration or ignite conflict? World leaders are already debating protocols as preliminary signals, if any reveal advanced tech. By March 16, 2026, Atlas will skim within 54 million kilometers of Jupiter, affording NASA's Juno orbiter, entrenched in the gas giant's domain since 2016, an optimal vantage. Juno's arsenal, encompassing wide-angle cameras, microwave radiometers, and radio science subsystems, could yield high-fidelity imagery while probing for anomalous radio transmissions or thermal anomalies indicative of engineered activity. Such detections would transcend speculation, furnishing tangible evidence of technological signatures. Juno might even detect antimatter-like energies or exotic propulsion residues, spurring innovations in energy and drive systems. This unfolding narrative isn't confined to academic circles. It permeates policy realms, as evidenced by an official document, co-authored by Loeb advocating for governmental preparedness against black swan contingencies, rare transformative events, precipitated by anomalous, massive objects traversing the ecliptic. The Trojan horse motif serves as a cautionary emblem. Ancient Troy succumbed to superficial deception. Contemporary humanity must pierce veils with rigorous scrutiny. If post-perihelion observations, including the acceleration, reveal further fragmentation and intensified luminosity consistent with natural disintegration, the enigma resolves mundanely. Conversely, structural integrity amid stressors, coupled with heat plumes, kinematic deviations, or the observed thrust, would corroborate engineered provenance, perhaps a robust metallic exoskeleton cloaked beneath volatile exteriors. Whispers from data logs mention variable spins and possible microwave signals echoing universal constants like pi or e. In my extensive career probing the frontiers of theoretical physics, from multi-dimensional string theories, unifying quantum gravity, to quantum computing paradigms, revolutionizing computation, and multiversal hypotheses, exploring parallel realities, I've often contemplated humanity's solitude amid the cosmic expanse. The Fermi paradox queries: if the universe brims with potential life, where are the extraterrestrials? Atlas proffers a compelling retort. Perhaps they dispatch automated emissaries, rather than broadcast signals, employing stealthy disguises to survey without alarming. Sophisticated societies might deploy von Neumann probes, self-replicating machines capable of exponential proliferation across galactic scales, traversing eons on fusion drives or gravitational assists, awakening only upon system ingress. Atlas might seed replicators, raising profound ethical questions about interference, replication ethics, and our readiness for such tech. Detractors contend that Atlas's quirks, including the acceleration, are reconcilable within naturalistic frameworks. An eccentric comet birthed in a remote chemically aberrant stellar cradle, its anomalies, mere statistical outliers, amplified by the perihelion stress. Yet as these idiosyncrasies accumulate, gargantuan dimensions, hypersonic pace, ecliptic precision, polarization extremes, inverted volatile ratios, metallic phased revelations, and now this precise, undetectable thrust, the probabilistic tapestry phrase, beckoning alternative paradigms. Loeb's sage counsel resonates. In this grand interstellar rendezvous, empirical observation trumps imaginative conjecture, drawn from cinematic tropes. Data logs show variable spins, perhaps indicative of attitude control. What revelations might the Mars flyby in 93 days bestow? A prosaic progression, with no further anomalies, or the ignition of epochal contact through additional maneuvers. Global observatories, from ground-based behemoths like Mauna Kea to orbital sentinels like Hubble and the upcoming Vera C. Rubin Observatory, are attuned, real-time data cascades, through collaborative networks. Should Atlas veer again, radiate unexpectedly, or fragment atypically, say ejecting non-dissipating objects, the annals of history pivot irrevocably. This juncture mirrors seminal breakthroughs: Copernicus dethroning geocentricity, Einstein reshaping space-time, the Hubble telescope unveiling galactic multitudes. Atlas could catalyze analogous leaps, elucidating novel astrophysical processes, extraterrestrial biochemistries, or interstellar engineering feats, perhaps even philosophical re-evaluations of consciousness's ubiquity. Probes might confirm panspermia, the seeding of life across stars, by carrying microbial signatures or genetic markers. Interstellar demographics forecast such traversals infrequently, but Rubin's enhanced survey capabilities could surge detections, normalizing these visitors. Chemotaxonomic analysis of the CO2 coma informs models of distant nurseries, while photometric modulations might hint at illuminations or rotations. Prospective missions could even launch interceptors for sampling, though fuel constraints make it challenging for such high-speed targets. Sociocultural impacts loom. The Halloween timing of perihelion added a spooky allure, with media documentaries and viral vistas amplifying public fascination. Counter-arguments persist, convergent anomalies from unmet models, but the holistic ensemble of evidence persuades toward openness. From my vista, Atlas represents enlightenment, challenging our cosmic isolation and hinting at company through subtle tech demonstrations. My overs extrapolate such leaps from impossible physics becoming possible to humanity's future among the stars. Culminating, the perihelion disclosure demands vigilance via inquiry. Profundity echoes Umulman's Yarazin under radiation pressure, Borisov's Genesis democratizing interstellar comets. Atlas heralds a new era of vigilance, with repositories of data democratizing access for citizen scientists. Epilogue: embrace the uncertainty, for it drives discovery. Gratitude for joining this odyssey, ignited by these revelations. Like the video, share your thoughts in the comments. Propulsion or natural fluke? What city are you pondering this from, and how does it change your view of the stars? The odyssey endures. Let us